This is Mr. Martin. These are the video notes for section 5.4 for Geometry Honors. Today we're going to be talking about four-sided polygons. There's a lot of information in these notes, so I would encourage you to go back and reread them several times to make sure that you're familiar with all the different polygons and their properties. So um, let's start out by defining what a polygon is. A polygon is a plane figure, and when we say plane figure, really we just mean that it's on a flat surface, and it has the following properties. They consist entirely of segments. The consecutive sides, the sides that are next to each other, intersect only at their endpoints. Each vertex must belong to exactly two sides, and consecutive sides must be non-collinear. So if you have any questions about those, make sure that you ask me. When we name a polygon, we start at any vertex and you proceed either clockwise or counterclockwise, doesn't really matter. So if I have some five-sided polygon here, we'll just give it letters A, B, C, D. We can call this polygon A, B, C, D, or we could call it C, D, make that an E, C, D, E, A, B. Okay, if it's a parallelogram, it has four sides. We'll have some special symbols, but most of the time you just A, B, C, D, E. We'll just, pick the letters, pick anywhere you want to start, and go all the way around until you get all the vertices. We're going to talk about convex and non-convex, or concave. If a polygon is convex, then each interior angle has a measure less than 180. So let's take a look again. Here's a pentagon, and you can see that each one of these angles has a measure that's less than 180. If we look at a non-convex, something like this, just pretend that my segments are straight here. So again, we have five sides. This angle is less than 180. This angle is, this angle is, this angle is. But you could see this angle here is more than 180. So one way I like to think about this concave is also non-convex is this side's been pushed in, it's been caved in. Okay, and most of the polygons we deal with are going to be convex. There will be a few instances where we deal with concave. Okay, so unless specifically stated, assume that all polygons are convex. Diagonals of a polygon. If a segment is a diagonal of a polygon, then it connects any two non-consecutive, okay, non-adjacent, not next to each other, vertices of the polygon. So let's take a look at a six-sided polygon, or a hexagon. So I've got A, B, C, D, E, and F. So if I want to draw a diagonal, I'm going to pick any two vertices that are not next to each other, that are non-adjacent. So I could pick, for example, A and C. So segment AC is a diagonal. Okay, so I'll draw that in. I have a diagonal. I could also pick B and E and connect those, and that's a diagonal. So segment BE is a diagonal. Okay, so non-consecutive, meaning if I pick EF, since these are consecutive vertices, EF is not a diagonal. It is, in fact, it is a side of the polygon. Okay, so a side of the polygon cannot be a diagonal of the polygon. Right, and then I could go ahead and draw all the different diagonals. There's a whole bunch of them. Eventually we'll figure out how many there are. These are two of many diagonals. Okay. Alright, so we're going to be talking at length about quadrilaterals and special quadrilaterals. So if a polygon is a quadrilateral, then it has four sides. And then we have all these different types of quadrilaterals. We have a parallelogram, rectangle, rhombus, kite, square, trapezoid, isosceles trapezoid. And let's quickly take a look at the definition of each of these. And then again, I highly recommend that you go back and read this several times and make sure you're familiar with these definitions. So if a quadrilateral is a parallelogram, then both pair of opposite sides are parallel. So what I suggest you do is take out some separate paper, and for each one of these definitions, we'll do it for parallelogram here, you're going to draw what the figure looks like, and then we're going to put, based on the definition, what we would know. So we've got ABCD is our parallelogram. If a quadrilateral is a parallelogram, then both pair of opposite sides are parallel. So based on this, both pair of opposite sides are parallel. I would know that AB is parallel to DC, and I know that AD is parallel to BC. Okay, so this is what I'm suggesting you do for each of the rest of them on separate paper, because there's not a lot of room here, so you'll do the same thing for rectangle, rhombus, kite, etc., based on what information they tell you in the definition. So rectangle, if a quadrilateral is a rectangle, then it is a parallelogram. So notice it's a parallelogram, so it's going to have these properties here, with at least one right angle. So if I take my parallelogram and I make one angle a right angle, think about what's going to happen to all the other right angles so that it stays a parallelogram. If a quadrilateral is a rhombus, then again it is a parallelogram with two consecutive sides congruent. And again, think about what happens when I take two sides that are next to each other and make them congruent. What happens to the rest of the sides? Then we have a kite. If a quadrilateral is a kite, then it is a quadrilateral with two disjoint pairs of consecutive sides congruent. This word disjoint here just means that they're separate from each other. Separate from each other. Okay, and then if you have questions about that, make sure you ask me in class. I'll draw some pictures for you. Then we have a square. If a quadrilateral is a square, then it is both a rectangle and a rhombus. So if it's a rectangle and a rhombus, of course it has to be a parallelogram as well. So these are these next two are a little bit different than the others. We've got trapezoid. If a quadrilateral is a trapezoid, then it has exactly one pair of parallel sides. If it has more than one pair, it cannot be considered a trapezoid. And then these parallel sides are called the bases. And then the other sides are called the legs of the trapezoid, so make sure you're familiar with that. And then an isosceles trapezoid. If a quadrilateral is an isosceles trapezoid, then its non-parallel sides are congruent. So these non-parallel sides, again, are called the legs, and they will be congruent. Okay, so what I want you to do in this space below is draw a family tree of these quadrilaterals. So we're going to start out here with our garden variety quadrilateral. I'll start you out here. So this is, let me fix this. Quadrilateral. Okay, so just any four-sided figure, nothing special about it. And then from this, you're going to have branches, maybe one, maybe two, I'm not going to tell you. And off of this, you want to put all of these different special quadrilaterals. So parallelogram, rectangle, rhombus, kite, square, trapezoid, isosceles trapezoid. So you want to build your family tree. And then based on that family tree, I want you to decide whether these are true or false. And we'll talk about these in class. And you can double check to see if your answers are correct, and we can double check your family tree. So I don't want to give the family tree away. That's why I'm going to let you do it on your own. I think it'll be really helpful for you. And then we'll discuss this a little bit further in class. Again, write down questions and ask me when you see me, and we'll see you next time.